In this video, I want to talk about some other properties of determinants. So I want to state a theorem. So if A and B are both n by n matrices, then the determinant of A times B is equal to the determinant of A times the determinant of B. Okay, and then secondly, the determinant of A transpose, it turns out, is the same thing as the determinant of A. Okay, so with this theorem, I'm not going to prove this theorem. Instead, I want to focus on how do we use it. Okay, so let's do an example. So let's suppose that A is a 3 by 3 matrix, and the determinant of A is 2. Let's compute the determinant of A to the 4th power. Okay, so how do we do this? Well, A to the 4th power means we have A times A times A times A. Okay, and now I can actually use one of the two parts of this theorem. I can use this first part. The first part says that if inside of a determinant, if I have some matrices multiplied, I can split this up into the determinant of the first matrix times the determinant of the second matrix, and so on. So this is going to be equal to the determinant of the first matrix, which is A, times the determinant of the second matrix, which is A, times the determinant of the third A, times the determinant of the fourth A. Okay, so overall what we have is, this is equal to the determinant of A to the 4th power. Okay, and now I know what the determinant of A is. It was 2. And I have 2 to the 4th power, which is 16. Okay, so the determinant is really easy to compute. It's really easy to compute the determinant of powers of a matrix, as we just saw here in this example. Okay, so let's do one more, but up the difficulty a little bit. So let's say I wanted to find the determinant of 10 times A. Okay, so the trap here is to say, wait, isn't this just 10 times my first determinant, 10 times 2, to get 20? It turns out that that's not true. So let's see why. So when we multiply 10 times our matrix, so times the matrix A, what we're doing is we have the 10 in front of our matrix. And our matrix here is 3 by 3. So it's got first row, so it's got a row 1. It's got a second row, so row 2. And then it's got a third row, it's got a row 3. And we've seen before in chapter 2 that when we multiply a matrix by a scalar in front, that scalar will multiply into every single entry of the matrix. So the 10 will multiply everything in row 1, and it'll multiply everything in row 2, and it'll multiply everything in row 3. Okay, so the reason why the answer wasn't just 10 times 2 is because it would be 10 times 2 if only one of the rows was multiplied by 10. Okay, but here every single row is being multiplied by 10. So the solution is actually that. So the determinant of 10 times A is going to be equal to something times the determinant of A. And what this number is it depends on, what are each of the rows being multiplied by. So the first row is being multiplied by 10, but so is the second row, and so is the third row. So I'm actually going to multiply by 10 3 times, or that's the same thing as saying I'm multiplying by 10 cubed. And 10 cubed, that's 1,000, and the determinant of A we knew above, that was 2. So I get 1,000 times 2, which is 2,000. And that is my determinant.